Vectors. A vector has both magnitude and direction. It's represented by an arrow. The length of the arrow represents the magnitude. The arrowhead indicates the direction of the vector. So let's look at this vector here. This point is your initial point where it begins, where the vector begins, and where the vector ends is known as the terminal point. The magnitude of vector PQ is the distance from point P to point Q. So this distance right here is the magnitude. We're going to use lowercase v to represent the vector for PQ. A zero vector has zero magnitude or direction. So basically, a point. It has zero distance and it has no direction. That would have a zero vector. Alright, when you have two vectors, vector v and vector w, and they're equal to each other, that means that they have the same magnitude and the same direction. Now let's talk about adding vectors. So for example, if we're adding vector v and vector w, we position so that the terminal point of v coincides with the initial of vector w. The new vector has v's initial point and w's terminal point. So let's take a look and see what that means. So vector v, again, we position so that the terminal of v coincides with the initial of vector w. And this would be our new vector. And that would be vector v plus vector w. Let's take a look at some properties. First, they are commutative. So vector v plus vector w is equal to vector w plus vector v. It's associative, so they can change positions and still be equal when adding. Zero vector, if you add 0 to a vector, v plus 0 is equal to 0 plus v, which is equal to v, so it does not change the vector. Okay, this is an important concept here. Vector v and negative vector v have the same magnitude, but opposite direction. Okay, so v plus negative v would cancel each other out. So for example, so what this looks like is, if you have vector v, and that's vector v, and then you add negative vector v, so that would be back the other direction, that would cancel each other out. Okay? Alright. Now, here we have vector v minus vector w. We would rewrite that as vector v plus the opposite of vector w. Okay? Next thing we're going to talk about are scalars. Scalars are real numbers having only magnitude. Okay, for example, temperature, speed, time. Okay? So if alpha is a scalar and b is a vector, then scalar product is defined as alpha times the vector. So we're going to look at page 610 in the book, at the yellow boxes for the definitions and properties. So page 610, if you would take a look at the yellow boxes and take a look at those definitions and properties. Right, graphing vectors. All right, let's go back here. For example, 2v, 2 would represent the scalar, and v represents the vector. Now the scalar has only magnitude, and it's just a number. Okay, graphing vectors. So let's look at some examples. So example A, vector v minus vector w. So we rewrite it as vector v plus the opposite of vector w. Alright, if you hear noise in the background, it's because I'm taping this within my 8th period class while they're working. So there might be some breaks to this video. So let's say we have vector v, and we have vector w, and we have vector u. Okay, so we have vector v minus vector w. So notice I took vector v and I redid it right here. It's 1, 2, 3 to the right, 1, 2 up. So 3 right, 2 up. So I redrew vector v. Okay, and now it's minus vector w or plus negative vector w. So instead of going down to right 2 from here, we go the other direction. So we go up to left 2. Right there. And so our resultant vector is going to be this one, from the original starting point to the final terminal. This is v minus w. Okay? Again, vector w went this way, so negative w goes the opposite direction. Okay? Let's look at v. So these have scalars. This one has a multiplier of 2 and a multiplier of 3. So that means we're going to multiply the magnitude of v by 2. So the magnitude of v, so I just went over 3 up 2, and I just did it 2 times. So I went over 3 up 2 for 1 v, over 3 up 2 for 2 v's, so that's 2v. Now I need 3 w's, so down 2 over 2, so down 2 over 2, that's 1. Okay, down 2 over 2, that's 2, and then down 2 over 2, that's 3 w's. And the resultant vector is 2v plus 3w. Finally, let's look at C. 2v's plus a negative w plus 1u. So 2v's. Alright, I'm trying to get my 8th period class to be a little bit quieter, but we're just going to keep moving here. 2v's. So again, 2 of these. So over 3 up 2, over 3 up 2. And then, looks like it's negative. I did negative 2 W's. So maybe I wrote this wrong. So let's see. Oh, it's just one. It's just one. Maybe I don't know what I did. It's not a 2. Just a typo. So back 1 W instead of this direction, went this direction. And then over 1 up 3. Over 1 up 3. So there's 1 U. And the resultant is your answer. There is ants crawling all over my stuff here. It's crazy. I see ants everywhere. Alright, moving along here. Alright, see these symbols? It's like absolute value, but it's a double bar. Whenever you see that, that represents the magnitude of V. It represents the magnitude of vector V, okay, or whatever vector it is. Okay, check out the properties on page 611. I don't feel like writing them all down, so please make sure you look at them. Okay, unit vector. Okay, that is vector V for which the magnitude of vector V is 1. That's a unit vector, okay? That might look something like, oh, that was it. If this is 1 unit, I guess you could say that's a unit vector because it's 1 unit long. Okay, the magnitude is 1. Okay, now an algebraic vector looks like this. Okay, we're going to use the less than and the greater than symbol here, but that's not what they are. But that's the symbols we use for an algebraic vector, where A and B are the components of vector V. Okay? If vector V is this, is an algebraic vector whose initial point is at the origin, okay, then vector V is called a position vector. The key here is that the initial point is at the origin. If it is, it's called a position vector. Okay? If any vector whose initial point is not at the origin, then it is a unique position vector. Okay? So, how do we write a vector using algebraic terms? Well, you know, you have your starting point and then your initial point and your terminal point on the vector. And this is the formula that you use to get the algebraic components. So let's look at an example. So here we have, we want to find a position vector. So we know that the initial point is here, the terminal point is here. So notice we do the little formula, x2 minus x1, we get 5. Okay, y2 minus y1, and we get 4. And there's your algebraic components. That's your position vector for this vector. Notice it doesn't start at the origin. Okay, so we have to convert it to this to get the position vector. Again, please see the theorem on page 612 on equality of vectors. Alright, this last thing we're going to cover right now is the components, writing them in this format. We have this vector can be rewritten as A times 1 comma 0 plus B times 0 comma 1. And 1 comma 0 is I, 0 comma 1 is J. This first component is your horizontal component. It's along the x-axis. Notice x1 comma 0. The J is going to be along the y-axis, and that is your vertical component. Okay, and we would write it like this: AI plus BJ. So here's an example. It's very simple. Here's your algebraic vector, algebraic components, and so we have, this is your horizontal, so 5i plus, here's your vertical component, 4j. Okay, now for assignments. Okay, your assignment's going to be on page. Alright, here is your assignment to get you started. We are in chapter 8, chapter 8.4, vectors. See you guys on Monday. Bye-bye.